G'day guys. Just going to look at the genes that affect dysbiosis, stuff like that. One thing that I'd just like to mention, I mean, dysbiosis is a sort of you could say a sort of a general term which has to do with inflammation. Now, obviously, inflammation isn't just genes, it's a number of things. So lifestyle factors, diet, stress, exposure to different things in the environment that can actually affect your gut microbiome. So there's a lot of different things. The sort of birth you had as a child, where you're exposed in a hospital to alternate type microbes, pathogenic microbes and stuff like that. Did you have shitloads of antibiotics and stuff like that? So, I mean, just a broad spectrum antibiotic can reduce your gut microbiome diversity by 75%. It's quite a big hit that your gut microbiome can take just from one broad spectrum of antibiotics. So there's a lot of factors. There's also the genetic factors that you could say, make you more susceptible. Obviously, if you're if you're on a species appropriate diet, you're managing stress, you're not, bombarding yourself with antibiotics, and you're basically in general good health on a good diet, on a species appropriate one, those genetics will largely be silenced. But it's always good to know which they are, because not all of us are healed. Some of us are still transitioning and stuff like that. And having a bit of knowledge about our susceptibilities sort of gives us a bit of an insight in, how much, you could say, leeway we have, in a sense. So it's just a general coverage, looking at part of this sort of leeway in that respect. Okay, let me just share that screen. Okay, so this is the NOD2 gene type. So basically those are all the SNPs. But we'll look at some of the ones that are a bit more important. Anyway, so this one here, there's a certain risk of autoimmune disorders and stuff like that. Generally speaking, Han Chinese don't have it, Japanese don't have it, Nigerians don't have it. This Indian tribe in Houston doesn't have it. These Kenyans basically practically don't have much whatsoever. Maasai, pretty much nearly 90% have very little. It's usually Europeans. So you can see it's about Northern Europeans are a bit the common variety, CC. They have far lower than everyone. Southern Europeans are the next group, about 70%, where Northern Europeans are about 60%. The ones that have got some susceptibility are about 30% in the south, about 40% in the north. The very high, the highest risk is about 3% and 2% in the south. Now, this group here of African ancestry in southwest USA tend to have higher So even though there is no other group, so they must have some mixed blood. And for some reason, that expression has been higher for that allele, but not for this one. Interesting, how things can combine between a number of generations and end up creating, different types of susceptibility profiles. Anyway, so the T is the risk allele for these type of things. So checking myself, that's the one. I've got CC, which basically puts me in the common group. So I've got the other one. This one's specifically for Crohn's. These two are of a lower risk type. So we'll move from the lower to the highest. GG. So that puts me into that risk category for this one. Actually, the worst one, 1.9, highest risk for Crohn's disease. So I'm and I'm using the Italians as a marker. There'd be similarities because there's a lot of Greek colonists from antiquity that moved to large parts of southern Italy, and so there's quite a bit there'll be similarities. So, but we'll use Italy as a southern marker, and obviously it's about 7% similar in the south. This group is slightly higher compared to this group. So also about a quarter, but Maasai don't suffer from any of these conditions, even though they're a quarter, and that little bit there is about 3%. Obviously, species appropriate diet doesn't create these problems. So obviously these are risks. It just means that, if you're not on a species appropriate diet, you're putting yourself at a greater risk. That's what it really means. Otherwise, if you're on a species appropriate diet, more than likely these genes are going to be silent, or their expression being very unlikely to be expressed. But there are other factors, as I said. There's the lifestyle, the stress, all these other factors that we have in the modern world that they don't have, and they are other factors that can actually be at play as well. So let's not completely discount them, and at the same time, let's not over elevate them as well. So that's the other one. Next one up. So TT for me, which basically puts me also at 4-fold higher risk of Crohn's disease. So again, I'm in the higher risk category. It doesn't surprise me. I used to have a lot of gut issues before I got on a species appropriate diet. I had plenty of gut issues, dysbiosis and stuff like that. I suffered for many years with gut issues. So I'm not surprised that I'm more vulnerable, and if I'm not eating species appropriate, I've got issues now that I've been eating species appropriate for a number of years, that those issues have gone away. Even my doctor, which I saw recently for my issue, basically made the same comment. I'm going to go and do some other additional tests, but I will bring all that up on the live streams. We'll discuss it then, not here. So check this one out. It's not determined, so I can't. And these are the key ones. That one, and that one are the key ones. So fortunately, that isn't determined, so I've got a new idea. But we'll look at it at least, and we can see again that the majority, I'm hoping that I'm in the CCs, the majority, there are no TTs, but there is, which is, but this is not a non-pathogenic, but obviously, so I'm in one of these two categories. More than likely, hope I'm in this. I don't need to have too many on. Anyway, let's look at this one. So G, the common one, thank the fuck for that, because these three are the key ones. So when you're looking at IBS and color and Crohn's disease, these are the three main ones. These are the sort of lower risk values. These three are the key ones. So at least I don't have that. So I've got low risk as long as I don't have one of these. Let's just check this one. And that's minus, which basically puts me in the common. So again, the three main ones, I do not, and this is the worst one out of all of them. So pretty much they don't show population one. Do they show population one on that one? Nope. So we don't have a population one on that. Just that one there. So these are the key ones that are the worst in terms of, Crohn's disease. Now there is another one, and this is another related one. This is also related to susceptibility to leprosy, but it's a variant of the NOD2 gene as well, with the risk one being C. And oh, wonderful. I'm susceptible to leprosy as well. Thank you. So that is the CC one. So amongst Europeans, it's up to 55.8% Northern Europeans, 56% in Southern Europeans. As you can see, Africans in Nigeria and all that, it's pretty much the Asians that don't have, and also this group in Kenya seems to be somewhere in between. Mexicans, but when it comes to Maasai, Europeans and all that, they tend to be in the more the risk groups. So European, Southern, Northern European, and the Maasai, and to a lesser extent the Kenyans, Africans, and Nigerians. Obviously, those from descent would be primarily do come from the same area. So you can see that both Europeans, and it doesn't surprise me because when people came out of Africa, they sort of branched off in that middle part, the Middle East and Central Asia, and one group went one way, one group went the other way. And so the group that went into Europe tends to basically has not adapted. And obviously the group, because we know that leprosy did come out of Asia, so it seems that a lot of these populations in Asia have acquired over a number of generations a higher level of immunity. I mean, there was an outbreak just recently up in Inner Mongolia in China of leprosy amongst I can't remember which wild animal up there. One of the wild animals up there. So it's well known. It actually, there's even outbreaks in the US occasionally that happen. But obviously with antibiotics today, it's not an issue. But obviously Europeans, Africans are the most susceptible populations. and the Middle Eastern populations. Doesn't surprise me because our exposure to it is far less. But this is another one that is associated with dysbiosis as well. So now let's move that to this part here. There's another group. Another type. This is the IL23R. So, which also determines the susceptibility. These are the two main ones. So genes that modulate susceptibility to Crohn's disease. So and Crohn's disease is just another, you could say another word for dysbiosis, gut permeability and stuff like that. So people that tend to have Crohn's disease are far more susceptible to these things than others. Doesn't mean that people that don't have those genetics are not going to get the condition if they're not on a species appropriate diet, but it just makes you more at risk. So the risk goes up because of those genetic traits. So we're going again from the lowest one to the highest in that regard. So in that regard, in this one for me, GG. So that basically puts me into that one. Wonderful. Thank you. And again, you can see the same pattern here. People in Africa, people in Europe, and people less susceptible in Asia for this one. It's the reason why we tend to find that amongst Africans and whites of European descent, the prevalence of Crohn's disease, irritable bowel disease, and all those tend to be higher than amongst Asians. So there's a good reason. They have a better adaptation to grains and those associated foods than we do. Simple as that. They've been exposed to them for far longer in their history and have acquired better immunity or better capacity to deal with those things, with those compounds. But that is as far as it goes. Obviously, they're still susceptible to fructose. And we know as fructose has been introduced in recent years into Southeast Asia and Northeast Asia, diabetes rates have gone up. So they're definitely not when it comes to fructose. But when it comes to basically glucose-based carbohydrates, those and their issues related to gut, they tend to tolerate those sort of foods much better and have less genetic associated with those conditions. So CC, which normal risk, thank fuck for that. And again, this one here isn't a big risk one anyway. So I've got the common one, which is what the majority of people have. This is more of a protective one. So do I have any fucking protection? It's not looking that good currently. No, obviously not. GT. Hold on, wrong one. That one. Oh, I've got a bit. And also spondylitis, which is good. And most of us See, everybody is in the normal majority, but some of us are in this advantageous group. So I'm in that. So at least that's good for the back. It's one up. So I got a stronger backbone, Blinky. Anyway, let's move on and continue looking at the gut issues. So even going back to that one there, even that, see, there's a normal sort of, the large majority of people, will be in the risk allele. That's what I mean. So that is why everybody, even on small amounts of carbohydrates, even when they have the best genetics, they're still majority going to be there. They're going to have some susceptibility. Right? So it's no escaping it. If you really want to silence all these genes, stick to a species appropriate diet is really the take-home message. But anyway, let's continue checking me out. CC. Obviously, I'd have to have the worst one, wouldn't I? Great. Baseline average risk. Actually, so the certain autoimmune diseases. So I've got a baseline risk for autoimmune diseases, but Graves' disease, I've got a 2.3 times. So I've got less of an autoimmune, general type of autoimmune, but I'm more susceptible to a Graves. Wonderful. And the majority of us are all over the place. So again, CC. When it comes to Chinese, they tend to basically be more of that one rather than Graves' disease, which tends to be higher in Africans and Europeans. Again, those differentiation of that group, the group migrations sort of explains that. Again, susceptibility. So EE. Oh, that's good. And the EE group. So, which is more the ancestral one. So G is the risk one. So that's good for that one. And this is a slightly, also has an issue with psoriasis. So those who have a GG tend to be at higher risk for psoriasis as well. Doesn't surprise me. So you're still, about 11% approximately. Some of these groups are much higher. Chinese are quite high. Japanese for susceptibility to this, to psoriasis. Interesting. So, yep. Just to cover that in that regard. But obviously, you've got to be eating species inappropriate or very bad shit to basically really upregulate this and end up with psoriasis. So it's not enough to basically, and there are other genes associated. This is another one associated as well. Which is basically another normal one. Thank the fuck for that. So CC is the ancestral. I've got a bit of change, but not at risk. And then there's, this one's the final one. So that actually a lower risk of certain autoimmune diseases, normal, but higher risk for certain autoimmune diseases. So I'm here. Let's just see. So the majority of the population is basically in this group, very highly susceptible. So very few of us have got actually real that are in these two groups. So I'm in here. Thank the fuck for that. But most people are susceptible. It's normal, they're normal, but they're all susceptible to this risk of autoimmunity. So it doesn't surprise me as we're eating less of a species appropriate, you know, with inflammatory bowel disease, you know, but not with celiac disease. So that one there is not related to celiac, it's related just to inflammatory bowel disease. But it does not surprise me that the levels of, because there's underlying susceptibilities, and when we move away from the species appropriate diet, we are increasing those susceptibilities. So those are some of those general SNPs, the general single nucleotide polymorphisms, and their associated alleles and those susceptibilities. It's just to basically, if people have done their 23andMe and stuff, they can actually just check to see what their susceptibilities are in regards to IBS, Crohn's, and general gut dysbiosis. I will be doing another future video on dysbiosis, and we'll be looking at covering far more of the bacteria that can be beneficial and help. At the end of the day, as I've talked before, there are very important reuteri and rhamnosus are two very important lactobacillus, and a number of the strains of those that I've talked before are really potent, you know, basically eliminators of things like C. diff and inflammatory type pathogens. At the end of the day, our biggest problem is things like stress, antibiotics, or misuse of antibiotics, to be more precise. The other thing is that when you take a broad spectrum antibiotic, your gut microbiome will collapse by 75%. You know, so you'll eliminate 75% of your gut microbiome within the first 12-ish hours, more or less. I've heard some people say in the literature a bit quicker than that. There are variations, but generally speaking, it's about that. So I tend to say if you have to take an antibiotic, if you have to, because you know you've got some gut permeability, you may have some sepsis, you've got to take antibiotic. Then what you need to do is basically within 6 hours after you've taken that, take a probiotic. And take a probiotic which includes a lot of the lactobacillus type and the bifidobacteria and stuff like that. Give yourself a B vitamin as well through that period with vitamin D to basically help restore that gut microbiome, because if you're taking over a couple of days a course of antibiotics, you're going to really ravage your gut microbiome. So you need to basically support it in between as you're trying to eliminate the pathogens. But ultimately, the ultimate way to dealing with pathogens, I mean, 40%, I think it's around 40% in the US. I could be wrong. If I am wrong, I do apologize. 40% of a lot of the actual sort of surgical procedures that happen in the US regarding to the gut are due to C. diff. So C. diff's a big one. Now, people can go and check my video on go to the microbiome playlist, and there is basically one there about Reuteri and the strain, the Swedish strain that actually suppresses and fights off and eliminates C. diff. So really important that people that basically have either taken antibiotics or that get onto that and basically deal a perfect blow against C. diff, take it out of the system. But you need to be supportive of the gut microbiome with, beneficial bacteria, looking at basically things like kefir, really important, and, high quality probiotics when you're basically doing a course of antibiotics. Now, obviously, you don't want to be taking the two together. You take the antibiotic, you give it 6 hours, and then you basically take the probiotics, take the Reuteri and stuff like that. 1, to suppress any pathogens. 2, to restore part of your gut microbiome, plus the B vitamin to support those beneficial bacteria to grow and populate, plus vitamin D is very important. The beneficial bacteria require much higher levels of vitamin D to function and do their job. So you need to support them if you're forced to do something like that. But generally speaking, if you've got these sort of issues, you need to support with these things. Remember, when we're talking about dealing with restoration of beneficial gut bacteria, 3 months, only 3 months, with a B50, no longer than that. And that's quite clear. And the B50 preparation that you get must have 50 milligrams of pantothenic acid, no more than that. The issue is pantothenic acid. If you go above 50 for over 3 months, you can induce basically insomnia. So not a good thing. And we can create over-vitaminosis, especially with pantothenic acid, since pantothenic acid does get stored. I did a video on pantothenic acid storage levels and stuff like that with Bart K. It's on his site. So that's why that's the issue. Many people don't know it. Specifically, a lot of people in the literature don't know it about this. I know Mary does, so because we discussed it once on my live stream, so she's up to date with that sort of stuff. But I've been up to date on that for a number of years now about the susceptibility, and that's why I brought up that study with Bart. So if anybody wants to go back and check that out, but let's not sidetrack. I shouldn't be sidetracking myself so those are the things you need to do. Now, obviously, none of this is medical advice. This is just basically to give you an insight on the genetics that have an effect on dysbiosis, and some of the strategies, general strategies that I would basically undertake if I was in that sort of situation. So anyway, I hope this gave you a bit of an insight on some of the genetics of dysbiosis and also some of the strategies that we can take. Always remember that when you're dealing with these sort of things, you need to basically work hard. Stress is a big thing. I'll give you an example in terms of parasitic parasympathetic and sympathetic. There's a lot that actually originates in the gut. 90% of the vagus nerve that goes from the gut to the brain, 90% of the communication is heading towards the brain. Only 10% is coming back from the brain to regulate the gut. That's just general regulation. So most of the signaling is happening in the gut. So if you've got problems in the gut, 90% of the signaling going to the brain from the gut is telling them that the brain, we're in a fucking mess. So that's why there is this gut-brain connection. If the gut's in a mess, your brain's going to be in a mess, basically, because it's 90%, not 1% or 2%, 90% of the signaling along the vagus nerve to your brain is going from the gut to the brain. Okay, so it's your gut's important, guys, for both your general health and your mental health and many other aspects. So do not neglect your gut, and do not assault your gut with species inappropriate foods. Try to manage your stress. Try to manage life in general on a number of levels. Also, taurine plays an important role, so it always should be part of your mix. Things like vitamin D, MK4, the fat-soluble vitamins, all these sort of things help in a number of different ways by supporting a number of different pathways. But at the end of the day, you've got to look after your gut. Really important, and minimize the assaults on your gut. The biggest assaults when it comes is processed food, emulsifiers, pesticides. All these things are very bad assaults on your gut. They all primarily come from plants. That's where the highest concentration of these things are. So get them out of your diet or minimize them as much as possible. Anyway, I hope this was informative in terms of general dysbiosis overview of genetics and some susceptibilities and some strategies to take. In future, I'll be doing more in depth in terms of specific strains that we can use. I mean, I've covered a few of these when it comes to C. diff and other things, but I'll be doing a more comprehensive, which strains and which probiotics combinations and how to use them are the best in terms of gut restoration. And that will be part of that video that I'll be doing down the track, hopefully next month, which will basically cover, it will be a comprehensive one on your basically digestive restoration. I haven't really decided on what exact name I'm going to give it to, but it's going to be in relation to that sort of stuff. So anyway, hope you enjoyed this. Anyway, see yous.